All right, in section 5, we're going to look at some different types of graphs of polar equations, and we will graph them and then just kind of look at some common polar graphs. So in general, just like we graph rectangular things where we pick x's and we pick y's and we solve for the other variable, you could do the very same thing in polar. In general, what we do when we pick points, though, generally we will pick some values of theta, and we will find the values of r. This will get us some points that we can thus use for our graph. Now, obviously, you can graph this on Desmos, get a really good idea of what your graph looks like, but in general, this is how we would do it. So this first equation, r equals 1 minus cosine theta, is what we call cardioid, and we'll look at a list of all these names later. R equals 1 minus cosine theta. So what I'm going to do is I'm just going to pick some angles, maybe 0, maybe 45, maybe 90, maybe 180, maybe 360, just some nice angles. And then I'll just plug these in. So for 0, my r is going to be 1 minus cosine of 0. That would give me a radius of 0. If I do 1 minus cosine 45, that's 1 minus the square root of 2 over 2, so that's approximately 0.3. The exact value is 1 minus radical 2, but it's about 0.3. Now for 90, we do 1 minus the cosine of 90. That's going to be just 1. For 180, we get 1 minus the cosine of 180. That's 1 minus negative 1, so that's 2. And if we go back to 360, that's the same as 0 degrees, so we would be back at 0. So if I plot these points, I have 0, 0, 0.3 and 45, 1 and 90, 2 and 180, 0 and 360. These are just some points on the graph, and then we'll use our Desmos to kind of fill in the shape of the graph. So 0, 0 is going to be there. If I go 45, which is on this spoke, I only want to go out about 0.3, so not very far at all. At 90, I'm up to 1. At 180, I'm at 2. And then at 360, I'm back to 0. So it's kind of hard to see what the graph looks like, but when I graph it on Desmos, what I see is it looks something like this. So this is what we refer to as a cardioid. So let's look at another one. This one is called a limicon with an inner loop. Just the name of the graph. So we want to try to see what this one's going to look like. So again, I'm going to pick some angles. Maybe I pick just the quadrant angles. You can certainly pick the ones in between. These are kind of our most famous angles. So then I'll find some of these things. So r equals 5 plus 2 sine theta. Oop, not theta, 0. That's going to give me 5. For 90, we get 5 plus 2 sine of 90. That's 5 plus 2, which is 7. And again, all these values you can just find in a calculator. Obviously, just making sure you're in degrees. 5 plus 2 sine of 180. Sine of 180 is 0, so this is just 5 again. 270 is going to be 5 plus 2 times sine of 270. The sine of 270 is negative 1, so that's 5 minus 2, which is 3. And 360 will be the same as 0, so that'll be back to 5. So if I plot some of these points, we have 5 here. At 90, we have 7, which honestly is kind of off our grid. 180, we're at 5. 270, we're at 3. And then we're back to 5. So we have these 4 points. And again, if I do Desmos, a limicon without an inner loop looks almost like a circle. It's a little more elongated to the horizontal. It looks something like this. All right, so what we have here is we just have kind of a listing of all the different kinds of polar graphs you can have. We have circles and limicons and roses, lemniscates, spirals of Archimedes, just depending on what the form of the equation is. So you can see if you have something of the form r equals a cosine or r equals a sine, you basically get one of these circles that's oriented to the right, left, up, or down. Limicons, you can see we have limicons with an inner loop, really just based on the ratio of the numbers a plus or minus b sine or cosine. So you can have one with an inner loop, without it. You can have this one's what's called a dippled limicon or a convex limicon. You have roses with the different petals and such, depending on your numbers. And then you have lemniscates. Lemniscates are just, looks almost like an infinity sign. For cosine, it kind of looks like this, and for sine, it's more slanted. So if we look at these graphs, I want to kind of know what kind of graphs these are, then I want to kind of sketch it. That's kind of our goal for this page. Now, most of these you can graph on Desmos, but just to use our chart, we can use our chart to kind of see, which of these kind of graphs this falls into, so we can get the, the specific name and such. So this first one says r squared equals 9 sine 2 theta. So this is going to kind of match this graph over here. We have r squared equals a squared sine 2 theta. So this is a lemniscate. So it's going to look somewhat like this infinity side. Now, this is the one that's kind of tricky to do in Desmos, because Desmos only lets you do positive or r equal things. So this one has r squared. So what you have to do is you just have to take the square root of both sides when you're entering it in Desmos. But I can also see that it's going to look something like this graph over here, going out to 3 on both sides. So it's going to look something like that. So that's our lemniscate. If I look at this one, we have r equals 3 cosine 2 theta. So let's look for that one. So we have 3 cosine with a number inside there, 2 theta. So if I look on my chart, that one is going to look something like a rose, because the rose has a number in front of the theta and then a number out front. So if I have 3 cosine 2 theta, 2 theta for cosine is going to be, so it's going to be similar to this sine one. It doesn't have a specific cosine of 2 theta, but very similar to this one. Cosine in general is more oriented around the axis versus the origin. But for this one, for this rose, let's go over here. So this one's going to be a rose, and since it's 2 there, the number of petals is going to be double that. If it's an odd number in front of theta like this one, there's always double that number of petals. And then the 3 is just how far it's going to go out. So it's going to go here, 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 and here. It would look something like this. And again, this is one that would be pretty easy to graph in Desmos because you're just plugging it in. All right, let's look at 4 minus 3 sine. So we have a number minus another number with a sign in front of it. So if we look at this, the one this best matches, I would say, would be this is one of our limicons, because we have a number, plus or minus, in this case it's minus 3 sine theta. So it's going to be one of these limicons in this kind of area. So we just have to figure out which one. And so we know that A in this case would be 4 and B would be negative 3. So if I do those two numbers divided, because it says take our A divided by our A divided by our B is going to be 4 over 3. So it's going to be some kind of cardioid, or some kind of dippled limicon. So it's going to look something like this. So this is going to be a limicon. Doesn't really matter which type, to be honest. And so if I sketch it, it's going to go up to 1, it looks like, and does something like this. All right, let's look for this one. This was just r equals -2 cosine. So that's going to take the form of a circle because it's just a number in cosine theta. So a is less than 0, so we're talking about this guy here. So this is going to be a circle that opens to the left. And since it has the 2 in front, it should go out to -2. So if I sketch it over here on my grid, it's going to have a diameter of 2. So here's -2, so it looks something like this. So again, most of this we really are going to count on Desmos to help us out, to graph it. And that is very typical when you do polar graphs because there's such a variety of graphs that can be formed that it definitely get a little trickier. So let's look at the last couple. We have 1 minus 2 sine theta and r equals 2 plus cosine theta. So let's see if we can't find 1 minus 2 sine theta on our chart over here. So we have a number minus a number sine, and if I do the ratio a over b, which is the number in front, which is 1 over the number in front of the sine, which is 2, I get half. So that's falling in this category because the ratio of a over b is 1/2. That's less than 1. So we get a limicon with an inner loop. So again, we saw this one before, but this limicon with an inner loop, if I sketch it, looks like it's going to go something like this and then have a little loop inside of it. So this is a limicon with an inner loop. Okay. So finally, we're going to do r equals 2 plus cosine theta. And we're going to see what that looks like. So if we look on our chart here, we're looking for which one looks like a number plus cosine theta. That's going to be in our limicon area again. So in this case, 2, which is the a value, divided by b, which is 1. 2 over 1 is 2. So I have this convex limicon is what we're looking at here. A convex limicon is not very exciting. It kind of just looks like a circle with like a flattened side. So when you look at graphing it, it's going to look something like this. Just kind of flattened out on one side. Okay. So those are just some examples of some different types of polar graphs. I mean, again, you'll see lots of different ones when you start graphing these on your assignment. But if you do have questions on any of these graphs, please do let me know.